Once the business goals have been defined and success metrics agreed upon, the next phase of any AI project under the CPMAI framework is data understanding. This is where teams move from strategic intent to the raw material that will power the AI system, the data itself. It's a foundational step, and how thoroughly it's done will shape the quality, fairness, and effectiveness of everything that follows. It begins with documenting what data has been collected. The initial data collection report captures where the data came from, what form it's in, how much of it exists, and how it was obtained. For example, one project might begin with a simple API pull from a CRM system, yielding 10,000 JSON-formatted customer support records. Another team might draw from a mix of sales databases, social media listening tools, and email marketing platforms. In one retail use case, a company combined CRM, sales, and social engagement data to create a 360-degree customer profile. This integration enabled a much more accurate model for predicting churn by capturing the full customer journey, not just isolated events. Once the data is gathered, it's time to step back and look at the bigger picture. A data source inventory helps teams understand what they have, what they might be missing, and how everything fits together. This includes both structured sources like relational databases and unstructured ones like chat logs or support tickets. Teams evaluate who owns each dataset, how often it's updated, and whether it contains personally identifiable information or other sensitive content. For instance, an internal billing system might update monthly and include financial data that requires masking for compliance reasons. This inventory isn't just technical, it's also a compliance and governance tool that flags potential risks early. Next comes a deep dive into quality. Even the most advanced AI model can't compensate for poor data. Through profiling tools or custom scripts, teams assess how accurate, complete, and consistent their data really is. Key metrics include missing values, data validity, duplicate entries, and outliers. In one healthcare project, a data quality review revealed that nearly 28% of patient records were missing diagnosis codes, an issue that could have severely undermined model training. The team responded by sourcing external health databases to backfill the gaps, turning a potential failure point into a learning opportunity. With the quality evaluated, attention shifts to how the data will be used in training and testing. Defining training and test data specifications means choosing a data split strategy, whether random, stratified by category, or time-based depending on the use case. It also includes outlining the input features, the target output, and any requirements for class balancing or time-sensitive holdouts. For instance, a team predicting customer churn might split their dataset 80/20ths, stratify by churn status, and include features like age, contract type, and tenure, while setting aside more recent data for final validation. Finally, teams define cognitive data needs more explicitly by using what's called a cognitive data requirement matrix. This tool helps identify which AI capabilities are needed, such as natural language processing, computer vision, or sentiment analysis, and links them to the specific types and volumes of data required. A project focused on sentiment analysis, for example, might determine it needs 50,000 textual reviews from app feedback, all in CSV format. If only 5,000 reviews are currently available, that gap needs to be addressed before moving forward with modeling. Throughout this phase, the goal is clarity, not just in what data exists, but in what it means, how it behaves, and whether it's truly fit for purpose. Teams emerge from this stage with more than spreadsheets. They gain insight into their readiness, risks, and possibilities. With that foundation, the project can move forward into the next CPMAI phase, data preparation, with confidence and direction.